Please welcome the Product Line Manager for Building and Infrastructure Design at Autodesk, Martin Schmid. Give him a round of applause.
Thank you. So hopefully you can hear me okay. Do I get a thumbs up or a clap or something so I know everything's coming through? Yep, all right, great, thank you. So as stated, my name is Martin Schmid. I am one of the product line managers. So we have, sometimes I feel like inflated titles, but there's several of us. We focus on Revit and other products, depending on exactly what our role is. I myself, I focus on a couple aspects of Revit. That's the electrical design portion, as well as the mechanical detailing aspects of it. And I, as mentioned, am coming to you from San Antonio, Texas. So let's just get into it. So if my slides can go up. I will be providing an update on MEP and what's new and what is coming as of the most recent releases. So before I get started, I do need to state that this presentation will be making statements regarding future events and development efforts for our products and services. These statements reflect our current expectations, and based on what we know today, our plans are not intended to be a promise or a guarantee of future delivery of products, services, or features, and purchasing decisions should not be made based on these statements. So with the legal verbiage out of the way, let's get on with it. So the agenda today, I will be covering very high level, some of the concepts that feed from our Autodesk strategy into our product strategies as we're making plans and decisions. I'll be covering specifically the mechanical analysis and design portions within Revit, same thing on the electrical side, and then get into what we're doing with mechanical detailing and fabrication with CAD, CAM, and EST, and the integration into Revit. So when we look across our vision and validating our roadmap, we can't make informed decisions without customer and industry influence. We're staying in tune with the key industry trends and external factors that play a significant role in how you succeed as a business. So to that end, we incorporate listening and things that are most important to you. So for example, we're constantly looking across the landscape of technology and how things are evolving with regard to cloud computing and how people want to use data and APIs to connect workflows. We're looking at the macroeconomic trends around globalization and, of course, the impacts of COVID-19, which has really accelerated the adoption of online technologies. And then, of course, the challenges within the industry, whether that's profitability, talent gaps, and project complexities, as we saw kind of in the intro video there. So all those kind of factors feed into kind of the broader Autodesk strategy, and then that, of course, feeds into decisions and so forth around product roadmaps. So in addition to that, we're also continue to invest in all the products in our product portfolio to expand their reach and their capabilities and make improvements generally. So this is critical to our customer success. Secondly, we also are looking to create meaningful integrations between different products instead of just having point siloed solutions. The idea is to merge with data and have connections between different applications through API and services, so that we could deliver best-of-class end-to-end workflows across products and technologies that we have across the ecosystem. And then long-term, the goal is really to unify these products and the workflows by delivering a unified platform where all features come together across building infrastructure design and, of course, into manufacturing and other parts of our portfolio. So this concept of convergence breaks down silos, creates new customer demands and needs and wants and desires and new industry structures. So, for example, silos can be broken between team members and skills can converge together. Functionality converges to common customer experiences. And then finally, new industry value chains and structures can emerge. So when we take that backdrop of kind of the high level, what's affecting every product within our portfolio and the technologies that go into them, and we take a reflection on specifically what we're doing on MEP, our vision and mission there is really to deliver higher performing buildings. Nothing should be surprising about the statement here: to deliver higher performing, more sustainable MEP systems with integrated analysis, coordination, documentation, and fabrication. No major changes there over the last few years. It's just a very concise way that we phrase that. The operative word here, however, is being integrated. Integrated means a variety of different things in this context. So what do we mean by that exactly? So this diagram provides kind of a very idealized picture of this. But it's reasonably complete in terms of breaking out all the key disciplines, roles, stages, and activities that we cover. So if you consider just the two main disciplines, that being mechanical and electrical, of course, plumbing fits into mechanical, and there's other sub-disciplines within all that. And then the main three stages and activities, that being the design and analysis, typically by degreed engineers, coordination and documentation by technicians, and then detailing and fabrication. That's at least 6 unique segments. But then, as mentioned, you can factor in a variety of different roles, sub-activities, and even contract styles. It breaks out to at least a couple of dozen unique segments, each having their own distinct needs and connections to upstream and downstream of one another. So for a product team, this is a lot of ground to cover. We obviously can't do everything for everyone everywhere, but instead of trying to provide, instead we try to provide certain core functionality each area. And then we look for where we can make valuable connections between those, hopefully making everything better and faster together. So many of you might recognize this graphic. We've been using it for a few years now to tell the story. But we keep asking ourselves and asking our customers if it needs to change, but it's really proven quite effective in articulating the breadth and the scope of what we're endeavoring to cover. So given that picture of all those disciplines and the roles and stages, and then that background strategy in the different areas that we're investing, we try to have an effective balance across that, right? So it's an effective balance between new and maintaining the legacy functionality and improving it. So that is, we're continuing to make things better. It's important to note that while we tend to highlight the shiny new things like analysis or fabrication, all our planning really starts at the beginning, at the existing functionality and what we can do to serve those users better. It actually occupies quite a large percentage of our time, and usually results in small but highly valuable improvements, such as those things that come from the Revit Ideas site. The common data experience is really how we create connections between them, and data is really the key there. The data is really locked up in individual applications now, but there's a variety of initiatives that we're looking to work through to be able to unlock that across our portfolio. And then finally, there's how we can bring all this together to create more cohesive workflows and sets of user experiences. So I say you try to strike an effective balance, but that does not really necessarily mean an even balance on a yearly basis. So for example, many of you will know that in recent years, you've seen us expand greatly from the core of that coordination and documentation where Revit really got its roots, and moving more into the design and analysis on the earlier side of project lifecycle, as well as into the detailing and fabrication end of that spectrum. So of course, that came at certain costs. Like for electrical, for a few years, we didn't have much in the way of investment, but we've been rebalancing that over the last few years, and now we're also rebalancing back into some of the core mechanical coordination and documentation functionalities that you'll see. So the key takeaway here is that we're happy to say that going forward, you should see more of an even balance across these efforts, across each of these areas, which ultimately will help us get closer to that mission and vision. All right, so this next slide, this is another way to kind of look at what we were looking at before in more how our customer base is organized, right? We have architects, they hand off certain information and involve design consultants, typically mechanicals, electricals, all within a common organization. In the ideal world, they would seamlessly share information back and forth together across design stages, and then certain information would go on downstream to the contractors, electrical and mechanical. Again, so it's idealized picture, more a reflection of how businesses are structured, but the reality is really something more like this. There's disconnects. Even within organizations, people can't necessarily communicate effectively. And so we see this as the great opportunity by which we can start to bring these things together across the digitization of our products and platforms. So looking at that prior slide in terms of the MEP workflow and this idea of convergence that we saw earlier, and reflecting on that, and as part of our higher level strategy, this slide shows one representative way that this could be applied. In this case, specifically to MEP design, though, the similar concept could be applied to other disciplines, be that structure, architecture, so on and so forth. So what this is trying to show is that each stakeholder is connected to the others, and they are all contributing their expertise to the digitized project information, and that information is used to guide and inform the contributions of others. Ultimately, creating a shared view of the project overall from which stakeholders can execute their work. So if we drill in a little bit more and take a look at this, what this means to have an integrated workflow, specifically about mechanical systems. Again, the same analogy could apply to electrical and other disciplines for the same concept. So in a mechanical workflow, early stages, a mechanical engineer is creating a design analytically and conceptually. They're identifying the key types of systems, identifying the zoning strategy, which will ultimately define various key organizational structures that serve all downstream consumers, right? The only reason that a mechanical contractor is installing ductwork is because that's associated with an air system that the design engineer put together, which was part of the conceptual analysis at that very early stages of design. It's all associated through kind of nomenclature and so forth to keep things organized. And that's what we're trying to connect that sharing of information from one stage to another. So from that design concept, energy and flow rates inform equipment sizing, and of course those quantities and sizes inform conceptual costs, which may include some rules of thumb at this stage, right? Because there's not a high level of detail in here. And that's why we have I have the telescope icon versus the microscope icon at this early stage. And it's not just about the cost, it's about the time that it's going to take to execute the project, the amount of energy that goes into, and how that building will operate over time, as well as the carbon footprint of that project. So all things that at that early stages, you have kind of rough ideas of what those overall costs in those different resources will be. Then, of course, as the project evolves, technicians provide more detail, which further defines that data about that project, enabling further clarity on the project. So getting equipment lengths or duct and pipe run lengths, electrical lengths, so on and so forth. So further refining kind of those costs and so forth throughout the project lifecycle of all those various resources. Then we dig in a little bit further, and of course, this is where users of estimating tools are really dialing in a lot more detailed quantity takeoff of individual components and their sub-elements and so forth, and taking into consideration constructability and so forth. So again, just another step towards that spectrum of starting with early costs and drilling more and more detailed as the project evolves and things become more clear under the guise of this kind of virtual microscope. And then finally, everything comes into detailed scrutiny, getting down to producing detailing for fabrication and installing, and having to account for absolutely everything that is needed as part of that project installation. So what we see happening here is that if we were able to better connect all these threads, integrated design across these stakeholders would enable people to better iterate towards higher performing, more sustainable buildings because they're sharing information across the various stages. Now, back in that diagram, you saw that loop back and what I've highlighted here is that green arrow. What that's intending to evoke is this idea that as data becomes more central to the way that we work, and that data is structured in such a way that you can learn from it over time, the idea being that then teams in the future could leverage project information that they've done in the past to inform decisions around new projects. We see a few customers doing this with technologies in a variety of different ways, logging information about past projects that they've done and using that to inform how they're working on future projects. You as engineers and so forth, you probably have rules of thumb that you're applying to do these sorts of things, but there are those out there that are trying to do this in a more automated way, and that's what we're looking to enable by having better structured data throughout the life cycle of projects within the MEP space. So that's kind of the backdrop of kind of what gets us up in the morning and excited about what we're working on here at Autodesk in our MEP groups. So let's look at what we're doing or what we've recently released kind of along that spectrum. So for mechanical design, really two key things here is that analysis piece, that first circle, if you will, and then that middle circle. So the analytical piece, we've made improvements to the workflow of navigation and increasing the accuracy and precision, and also increasing the model performance. And what that all means is that the mechanical systems analysis will do a better takeoff from the architectural elements. We're simplifying the way that takeoff happens. So instead of a lot of surfaces that might represent something like a complex curtain wall, we could rationalize that down into fewer surfaces, which then results in a faster analysis throughout that cycle. In addition to that, there is aspects of coordination and documentation. One of the big things that's been a long-standing pain point within Revit is the challenges around phasing. So historically, when you demolish elements within an MEP system, those elements would lose their association to the system. They would also lose their connectivity to adjoining elements. So if you needed to make modifications, nudge things around, you were doing it one piece at a time. And so the improvement here ensures that the components maintain their system information. And the reason that's so important is that that's how typically views are set up. Views are typically set up based on showing different elements based on different systems and different views, and using view filters to do that. And historically, because that information was lost, it was difficult to find ways to work around that. So that's been resolved for the 2023 release. And then in addition, there's some other things that we've added. So new categories for mechanical control devices. So things like humidistats, thermostats, as well as plumbing equipment. So again, it's around this idea of providing more flexibility, more control, giving you specific categories to better define your views. And then some improvements around tagging. So pipe segments, duct segments, so on and so forth. Historically, when you tag those, it would always tag the elevation relative to the level that that thing was associated with. But depending on what country you're in and guidelines and what stage of the project, some people need that relative to like a project base point or the survey point or sea level or whatever the case may be. And so we've added that capability in this latest release. And there's a lot more properties on the segment. So you can see that there's like upper end of the insulation at the lower end of the pipe, upper end of the pipe, so on and so forth. So a lot more flexibility in how you could tag things. And then the last one on there is rehosting connectors in Family Editor. This is, it's one of those small but mighty improvements for people that are really cranking out creating content. Whereas historically, if you needed to move a connector, you would have to delete it and recreate it. Now you could just move it or use the rehost functionality to make that happen. All right, so moving on from that into the roadmap. So these are the things that we're currently working on. So there's always more that we could do on the systems analysis piece, more detail, more precision, more accuracy, more speed, so on and so forth. Make it easier to use, easier to get into, and so forth. And so those are things that are kind of front and center there. That feeds into our evolution of what we're calling next generation Insight. So Insight is our cloud systems analysis tool and also supports Total Carbon. So that's another piece that we're investing in. And then the last big bullet there is analytical to fit physical model connections and automation. So what that's about is today we have the systems analysis model, and then we have the physical model. And there's not a direct relationship between the two. Ultimately, what we want to do is be able to connect those so that if you need to rerun analysis because it changed to the architectural model, that information can flow just even within the product across those stages, which doesn't happen today. It also provides the opportunity to start doing things like automation of automatically sizing equipment and automatic layout that we see some people doing with Dynamo and so forth even today. And then the rest of the items on this list are things like idea stations. So the first one there is on-off control for MEP connectors and family. So again, this is one for people creating and maintaining content where today, if you have similar things that you might have a manufactured product that has different options by which that thing gets connected, you have two options. One is to create multiple instances of that family, or to end up with disconnect markers throughout the project because you don't need to connect to all of them. So that's an improvement that's planned to simplify that content management aspect. Some improvements around the way that insulation interacts with piping across phases and through hiding things and so forth. There's planning to add split with gap for MEP elements. So that's something that's been on walls probably since day one with Revit, but we've never had it on pipe, conduit, cable tray, so on and so forth. So that's an improvement that we have in our preview release now already, actually. And then we're just adding a parameter for the pipe wall thickness. So that's something that, certain geos, that's something that's commonly annotated on the pipe along with say the diameter or the service abbreviation, for example. And then we're adding those elevation parameters that we added this year. We're adding those into the view filters. And then we also have on our roadmap this notion of auto dimensioning to help automate the process of laying out dimensions across MEP services. Okay, so moving on from mechanical into electrical. This is kind of a big year for the electrical side of things. So a couple years ago, mechanically, we released what was called this mechanical systems analysis framework. This year for electrical is kind of the reflection of that on the electrical side. In that we're providing a new workflow by which early stage conceptual design can be done. So there's a few key pieces to this workload. The first one is this idea of area-based loads, where you can define over the floor plate, whether it's a linked Revit model, where it's linked in PDF or DWG, you could link that in and create these area-based elements, assign that area-based element to a load classification, whether it's for lighting of different types or for your mechanical services or just general power, assign that a power density, and then use that as the basis of a load takeoff. So this is a common first step in electrical design that people today, they do across spreadsheets. They might be using Bluebeam. They might be exporting things to AutoCAD and so forth. And so this is the idea here, is to really centralize this into a Revit-based workflow with the intent that down the road, we can then start to connect that to other aspects. Again, that idea of that analytical to physical connection. And then there's a couple of smaller things on there. One is we added the circuit number property on electrical equipment. And then we've added some nested annotation improvements. So just scenarios where the annotation symbols were coming out reversed, things like exit signs that have a directionality to them. So some improvements around that just to improve the documentation and avoid various workarounds there. So I have a quick video here of this new electrical workflow. So as mentioned, this works with LinkedIn PDFs, DWGs, linked Revit models. But the idea is just quickly create a sketch around the building, around different key areas. So here I'm isolating the corridors. And then I'm like assigning different power densities. Like a corridor might have one type of lighting with one power density, whereas classrooms or those offices, whatever that might be, might have a higher power density. Or you might have different other usages, right? Corridor general power might be different from classroom or offices or whatever the case may be. So it's just a matter of kind of sketching all that out, assigning those key parameters. And then in addition, you can add other what we call equipment loads. So I can add in the notion that I'm going to have an elevator. I might know my key mechanical equipment at this point, depending on where the mechanical systems analysis, so I could capture the chiller or other mechanical components. And then I could start to build up my system hierarchy. And with this, you could define multiple power sources. So you could have utility power, you could have backup generator power with transfer switches, and then start building up that hierarchy. So you can see there I've added the main distribution panel. Of course, you could build this out as much as you like at this stage. But with a very few clicks and without having to go out into other applications, you can see that the total power on that quick takeoff is about 250 amps. So that helps inform kind of next steps. And of course, you could do this across multiple levels and so forth to dial that in. So that's a big one for this year. And then this is also one of my favorite electrical enhancements. Actually, it's not even electrical specific. This was an enhancement by one of our platform groups, but specific for electrical, the challenge that this addresses is a lot of times with electrical components and devices, things are very tightly compacted. And because symbols are exaggerated sizes of themselves, right, you might have receptacles overlapping other components or a fire alarm strobe directly over a light switch or those sorts of things. And so conventionally, people would move those, like in drafting paradigms, just move them out of the way. Well, since these are model-based elements, if you move it in one view, it's going to affect other views. So a few years ago, there was this idea of displacing elements in 3D views. And so this has been implemented similarly to be able to displace elements in 2D views. So I'll go ahead and let that play. So it's really simple. You don't have to modify the family definition or anything like that. You just have this new capability to move that thing out of the way. You could add additional annotation if you so desired, if you needed to explain what is going on, but you can see I moved that in the 2D view and the 3D view isn't affected. So a big win, so to speak, from the platform to improving electrical workflows. Okay, so moving on into electrical, what's new on the roadmap, I should say, is these analytical capabilities. So building upon what we've done with that area-based takeoff and conceptual distribution system, there are certain aspects of that that need to be considered. So for example, if you have non-coincident loads, so this could be things like mechanical equipment that need to be energized, but not all at the same time. So for example, you might have a battery of pumps where one is there for redundancy and they don't all operate at the same time. You need to take that in consideration so you're not oversizing your electrical distribution. Similarly, you could have equipment that has different operational states. So for example, equipment that only runs during heating seasons or equipment that only runs during cooling systems, they won't run at the same time. So another scenario where the electrical system could be optimized for what's non-coincident loads. So that's kind of the next step in that analytical workflow. And then there's also a relatively small improvement related to that of improving the visualization of those lines and those takeoffs. So today even now you could create multi-level lines. So if you wanted to do an outline of the entire building, you don't have to sketch it. You don't have to trace it on every level. You can just do it once and say that extends for multiple levels. But then it introduces the problem that, well, you don't necessarily know, well, if I move this line, am I just affecting this view or am I affecting multiple things? So just a way to visually distinguish that to have that awareness. And then also related to that electrical design takeoff and into this idea of the analytical workflow feeding into the physicality, the next step there is really addressing feeders and cables. So historically, Revit's only had wiring in their individual wires, and it's also always been on the American wire gauge. We haven't really accommodated kind of global needs around being able to have cables and use those as feeders throughout the distribution system. So we've started building out the functionality to be able to capture those things, not just for a global audience, but then also be able to capture that at that conceptual stage. So again, even at early stages when you're doing these takeoffs and you're starting your design process, you start building up your feeder schedules, which then down the road would feed into building out that from the physical standpoint. Then the next bullet here about support for 2D and 3D model-based views, this is actually quite a big one. The idea here is that Revit is really built around this idea of generating views of a 3D model. Well, in MEP design and planning and data visualization and so forth, there's a lot of needs for not just charts and graphs, but specifically around schematics, risers, one lines, those sorts of things. And Revit doesn't really have platform support for those sorts of things. We've seen users do creative things in drafting views and even use model views in a schematic design mode. But what we're building here is to start providing the foundation so that we can start putting into place actual functionality to support this idea of engineering documentation that requires more of a schematic representation. So that's a big one. That's in concert with another initiative that I'll talk about here in a moment. And then the last one on here is just showing additional connector information in the system browser. So today, there's additional information on, say, on electrical connectors in this case. So for example, the power factor, the load classification, and some other properties that you have to go into Family Editor to find out how those are set. You can't see what's going on within the project context unless you set up all sorts of additional parameters. So we're going to add those things to the system browser to make that easier to, drill in to understand what's going on in your project as a QA tool. All right. So the initiative that I referred to, tying into that 2D and 3D or non-2D and 3D views, is this partnership that we have with Schneider. So this is Schneider Electric that we announced a couple years ago at Autodesk University. And what this is steeped is in our shared vision of BIM for electrical design, and this idea of having integrated engineering starting at very early stages and then driving that information through the entire life cycle. And then using that connection between those early stages, the design concepts in mechanical, to establish what's known as the new energy landscape, and being able to use that as the basis of design so that early on you can start incorporating concepts required to alternative power sources and those sorts of things throughout the project lifecycle, and not be kind of an afterthought as it is in some cases today. And ultimately what we want to do is, as in this partnership, is make it easier to do use analysis for early and detailed design. So what you see there on the screen are some screenshots of some conceptual mock-ups of things that they have within their IP portfolio. You're seeing a keyline diagram, you're seeing a generated load letter based on that preliminary analysis, and then you're seeing a one-line diagram. So we're providing the platform to be able to create those kinds of views within Revit, and then we're working together to bring solutions to bear within an integrated Revit workflow. All right, so that covers the mechanical and electrical design. Just do a quick time check. All right, so moving on to mechanical detailing. So I'm gonna have to speed up here a little bit. So as mentioned previously, we always start our days by looking at how do we improve our existing products and products in our portfolio. So there's ongoing fixes to CAD, CAM, and EST. And then the rest of these items, I actually have individual, let's see, a couple of them I don't. So the first one here is this improvement around flip controls. This was released. These were always on the design elements. They just never existed on the fabrication elements. So we've added those. And then similarly, another control that we had in Canvas was the ability to modify the elevation of components. Historically, again, those were on the design elements, but not the fabrication elements. And then I'll drill into the rest of these in future slides. All right, so as mentioned, start our day, we're always looking at how we can improve CAD, CAM, and EST. So obviously this is a bit of an eye chart just to reinforce that notion that we're still breathing life into those tools. And they're part of our vision around connecting the Revit-based modeling workflow into downstream consumption for manufacturing and prefabrication and construction and installation. So one of the key things in this release related to that was historically, a lot of patterns had inconsistent behavior when it came to dampers. So when those components were developed, the holes for the damper rods would be in the wrong location or rotated incorrectly. And so as you can see there, the quote that caused a lot of manual pattern modification in the CAM environment, which could cause production delays, extra hours, and so forth. Especially if it wasn't cost, it could lead to waste, having to patch things, so on and so forth. So this was something that we spent a lot of time on refining that and providing consistency. And that's kind of a theme that we're going to have in different areas within the fabrication products moving forward. So this really breaks down into our roadmap into these kind of 4 key areas: fabrication data quality, so improvements around how those developments work. Connecting design data and filling detailing gaps. So the big one there is starting to connect the design data, such as flow, onto the fabrication parts, and working to start resolving differences between the design and the fabrication part behaviors. Again, starting with flow in that, and then other gaps, starting to fill those. So today in Revit, we don't have stiffeners, we don't have broad support for supports and hangers. There's very basic rudimentary functionality from the ITM-based elements. What we're working towards is having a proper foundation so we can have far more flexibility and how those work within the Revit environment. And then, of course, there's ongoing productivity improvements, and then I'll touch on the Fabrication Data Manager. So with regard to fabrication data quality, as mentioned, there's a lot of different buckets here that we're just going to chip away at time. Kind of the key message here is that if you're running into issues in these products, we definitely want to know about them so that we can plan to see how we incorporate those things into our vision of workflows moving forward. So yeah, please do let us know if you run into challenges, because as we're working through these, we want to make sure that we're doing a comprehensive job of it. With regard to filling detailing gaps, the 33% here, that's to reflect the fact that when, like a given mechanical contractor, for example, 1/3 of their work is approximately focused on sheet metal, 1/3 of their work is approximately focused on piping, and then 1/3 of their work is focused on materials for supports and hangers and so on and so forth. And we haven't invested proportionately to provide a similar level of capability within Revit. And then when we look at the way the fabrication products looked historically, there's a lot of gaps in there. There's not capabilities like beam clamps and beam joist grips and embeds, and being able to create complex tiering of different trapezes, so on and so forth. So there's a lot of variety of that people are working around with, like a lot of blocks and manual placement and then manual maintenance and so forth. And so we're trying to build out a platform to really support all the various aspects of supporting MEP systems generally. So to that end, we're starting with stiffeners. And the reason we're starting with ductwork stiffeners is because they're a subset of the complexity of supports. So when you think of a support, it not just connects to the duct, but it also needs to connect to a structural member. Whereas with a stiffener, it's just the member itself. There's a lot of common components, structural profiles, threaded rod, unistrut, those sorts of things. So building up the way that we can build those things and connect them within the Revit environment, build in the common Revit behaviors across those things, sizing, moving, copying, all those foundational things that all Revit categories would be expected to have. And then ultimately, even though these are planned to be Revit family elements, being able to connect that into the cost and labor information by way of Fabrication Data Manager, which we'll get to in a moment. So this is just a brief visualization. This was from, this is what you can see in our preview today, of being able to place these stiffeners, move them, have different types, interior, exterior, define them however you like. You can move them, create additional instances if you have conflicts that you need to deal with. And they move with the hosted element, they move with the duct, they resize with the element, and so forth. So building out all those core capabilities of new element types within Revit is not a trivial task. So we have manual placement in place. Next step is to automatically create stiffeners, being able to look at the specifications within the fabrication configuration to automatically create the different types of stiffeners that you would need, and then work on automatic placing along the run on the various elements, and then react to changes of size, length, as well as the specifications if those happen to change. All right, so that's kind of the big piece there to feed into being able to then do a similar thing for supports generally. And then here are a few kind of quality of life improvements. There's in Revit today, when you have working with walls, doors, and windows and so forth, when you place doors and windows within a wall, the door and window automatically kind of knows how to orient itself based on the cursor position. Whereas in MEP, you're always kind of manually having to tell the software what to do with extra clicks. So this first is an improvement just about Revit being reflective of where your cursor is to make it easier to place things. And then we're working on functionality to be smarter about automatically orienting fittings, so that if there's different types of connectors, threaded versus grooved and so forth, and you have a fitting that has those different types of connectors, that will automatically orient that connector, that fitting for you. And likewise for gender. Today, it'll let you place it and tell you that, hey, these things don't match. Whereas moving forward, it's automatically going to orient that for you. So again, just quality of life improvements. And then the last one here is the fixed relative option on that you could set on fittings. And it's not just a matter of enabling that option so it can be placed as a tap by default, but so that those components behave as expected in routing, trim and extend behaviors, and drag to connect that we added in the last release. All right, so the last piece here is related to the overall fabrication workflow and data evolution. Again, going back to that idea of convergence. So today, the fabrication products, CAD, CAM, and S do a great job of communicating across one another and sharing that data. But in the future, what we're driving towards is having that data cloud hosted in what we're calling Fabrication Data Manager. so that then that information can be shared across other products and services. And not just for model authoring, but for downstream work for manufacturing, creating development as a service, nesting, and seed generation, and so forth. To be able to integrate those workflows, not just in a desktop product, but across more modern applications, such as what we're building out in the Autodesk Construction Cloud, through partners like Stratus, but then also through generalized solutions like Microsoft Power BI and Automate and so forth. So this is kind of a brief overview of how this works today. So today, when with our technical preview of FTM, you can upload your configuration. Once it's uploaded, there's some backend processing that happens to make that data more cloud resident and cloud native to be able to make modifications on the cloud instead of just a bunch of individual files. So once that process, it becomes available, and then I could go into the website to make modifications, look at the data, share it with others, and so forth. So I'm going to drill in here into the part browser. And one of the unique things is we have this, what we call this relationship browser. And what that allows you to do is see all these relationships of all this data. So historically, it would be very difficult to understand where a part is being used. Whereas now you could drill into that part, you could see exactly which part template and services that's being used in. So that's kind of an idea throughout all the different types of relationships that happens in here. So as I mentioned, we can also share this configuration with other users. So I invited a colleague to be a contributor. So you could share it as somebody that has read access or just read access or read write. So once you share that, then the other user can also use this desktop sync tool to sync that information down to their local machine. And then once they've done so, then they can use that configuration data within Revit without you having to distribute files using other product services, copying files around, so on and so forth. So once they've brought that in from a cloud configuration, then at that point works just like a configuration that was on the desktop. Okay, one thing I want to show here is also that we have some editing capabilities here, services, part templates, all the various types of specifications, as well as connectors and materials. So just as a quick demo, I'm also going to show creating a part template. So if I had a new project that had a new set of piping requirements, so I might have this new heavy soil set of components that I need to work with. So I'll create that new part template and just add a palette to that template. And then add a few parts. So drill down and grab in my pipe segment. So grab that, add that part to the template, and then do the same thing with a variety of fittings. So I just go down and grab a handful of fittings and add that to the template. So this is the idea of adding all these kind of data editing, configuration, modification, and so forth capabilities into a cloud environment so that this data becomes available to other, not just within Revit, but across the Autodesk ecosystem and other products and services. So I've created my template. Now I'll create a service. Just give it this name of sewage, and then select that heavy soil part template that I just created. Apply that. Now you'll see in the sync tool that that's unsynced. And all it's doing now is downloading the delta. And so that's a much quicker operation. And now I could go into Revit and go to that cloud configuration. And there is the new service that I just created. So again, being able to make all these modifications in a cloud hosted way to make it easier to manage moving forward. All right, so this technical preview that I mentioned, it's been piping focused. You didn't see things in there related to notches and seams and those sorts of things. That's to come. Piping focus has been released. You could play around with this, demo this out in Revit 2022 and 2023. Our next big chunk is starting the creation process of various parts and components within the model. And then beyond that, then we'll start focusing on the sheet metal components and then ultimately driving to starting to connect APIs into that to be able to do quantities of cost and labor extraction, generate flat pattern developments, and do nesting and so forth via cloud services. All right, so that was a bit of a whirlwind there, I recognize. But again, in summary, it's really kind of these three pillars around integrated systems analysis to drive design and fabrication, start putting into place things that can help out with automation, some new functionalities coming around design analysis, and then ultimately detailing and fabrication, ongoing productive quality improvements with it, CAM and EST, and then filling out the gaps within Revit for mechanical detailing. So with that, I have a couple of brief QR codes there. One is a brief feedback survey. It's just 2 questions. What did you like? What were you pleased with about what you saw on the roadmap? And the other one is what are you disappointed that you didn't see? What's missing? What would you like to see in the future? And then there's also a QR code there for the Revit public roadmap. Okay. So with that, I don't know if we have time for any Q&A. If you have any questions, kind of constrained to the roadmap, would be great. But if we have a few minutes, I'd be happy to entertain those if the moderator is available.
Fantastic. Thanks, Martin. Thank you for that insight. Looks like you guys have been doing a lot of work there, and I think a lot of our guys hopefully got a lot out of that particular session. So I know I did, and great to see that your roadmap there. But I might reach out to the audience here and see if there's any questions. We'll see if maybe while people are having a bit of a think, we'll see if we've got some online. Okay, here's the first one here. We would be keen to be able to connect a flex to a duct fitting, i.e. a transition or cap end, and maintain system connectivity. Is that possible or in the works?
I'm not sure I completely understand what is being asked. I don't know the details. I would need to understand a little bit better to say.
Yeah. So we'll maybe see if whoever wrote that question online can add a little bit more detail there. But we can move to the next one here. Is there any work towards having the fabrication database modified natively in Revit?
No, not natively within Revit. There's a big drive around actually, again, this idea of creating connections of products and services. So that's why we're investing in Fabrication Data Manager, is to create a cloud-based repository. In fact, you'll see other examples of that. So with the 2023 release, there's also another technical preview for the shared parameter service as another example where shared parameters are shared centrally through a cloud service, but directly connecting and interfacing with Revit. So that's kind of the theme that you're going to see with regard to how products are going to be architected moving forward.
Yeah, sure. Thanks, Martin. So we have another one here. Can third-party Revit software families created by manufacturers be incorporated into this program? I assume that's talking about the FDM.
Yeah, potentially. I mean, that's our focus right now is on customers being able to maintain their existing libraries, but over time, that's certainly part of the vision of making it easier for content creators, manufacturers, distributors, and so forth to make their components available. It's not part of the short-term plan, but it's part of the longer-term vision. Again, going back to that idea of kind of distributed products and services.
Fantastic. Any questions from our audience in person? No, I think we're all good. Well, thanks again, Martin. I might just hand over to Charlie.
All righty. Well, thank you, everybody.
Put your hands together for Martin.
My pleasure to be able to present you.